Okay, there we go. Okay, so first little introduction. For those of you who don't know me, my name is Katya Prince. I'm with Prince Consulting. I've been programming since the early 90s, and I've had my business, Prince Consulting, since about 1998. And when I was in graduate school, I was also introduced to image processing and image analysis, actually even before LabVIEW. And I'd say that like every 3 to 5 years, I have an image processing job. And the leaps and bounds that have happened in LabVIEW in terms of being able to do these various image-specific functions has been phenomenal. But what I'm planning to do today is to give you a 10,000-foot view of image acquisition and processing. We're not going to get into like the specialty image processing that you hear about these days with stuff like intelligent, AI type of driven stuff, or there's now applications where you can render 3D objects with cameras and stuff like that. We're not going to do that. We're going to just talk about relatively basic image processing. So the first thing you need to ask yourself is, what is a good fit for vision or image processing? What are good applications for this? There are lots of good applications. You can find faults in things and cracks. You can measure the size of objects, look for presence and absence of objects. It's a way to do non-contact measurements and also take measurements of something where you can't physically get a piece of equipment in, and then also be able to make multiple measurements on an object with one single image. So I've been doing this long enough to remember back in the day when NI had field sales guys, field gals too, and they would go out and they would give presentations in various hotel ballrooms talking about data acquisition, trying to get engineers up to speed in terms of using a DAC card and collecting data and displaying it. And so they would always have this tenet. All of their talks were acquire, analyze, display, acquire, analyze, display. Well, what this talk is going to be is basically that same sort of presentation, but when you're doing image analysis, there's a larger step involved. And the analyze is not just analyze, but you also have to process that image before you analyze it. And processing is really just going to be what you need to do to the image in order to get to what you care about, separating that object from the background, basically. So the first thing I'm going to talk about is acquisition. How do you actually get information into the computer? And basically there's 4 things you're going to need. You're going to need lighting, you're going to need cameras, you're going to need some sort of a frame grabber or an interface, and then you're going to need the drivers. Now, if you look on this list, you can see that I actually put lighting first. And I think lighting is actually the most important thing when you're doing image acquisition. You don't care about the object. You care about the light that's bouncing off that object or through that object. And that's really what you should be focusing on in your application. So first thing about lighting is going to be what types of light sources do you have out there. There are probably a few, but nowadays, LEDs have really taken over that market. There are other sources out there. This isn't the only one, but LEDs, and I think LEDs are actually the reason why vision has become so powerful, because they have the advantage over other incandescent light sources in that you have the longevity of the sensors. You have a variety of form factors. You can get LEDs and rings and plates and lines. Obviously, they have a much smaller footprint than incandescent sources. They take much less power than those sources did. And you also have the option of having now single color. And I'll show you an example of where that might come into play. And then the other thing you might want to consider when you're doing image acquisition is strobing. So you may have a situation where you need a very bright source, especially if you're doing high speed. If you're doing high speed acquisition, your shutters are going to be very short. And so you need to increase the amount of light in order to get a decent image. Now, if you were to have a super bright light on all the time, you're going to run into a lot of features or a lot of issues with heat and with the longevity of your sensor or your light source. So you can use strobing to give you a much brighter, intense light that's synced up with when you want to take a picture instead of being on all the time. The next thing you need to consider when you're doing image acquisition is the orientation of that light relative to the camera. And in this slide, I have 4 examples of different configurations that you can consider. The upper left-hand corner has basically direct illumination, and this is what people usually do when they first start out. They just shine a light directly on the object, and that's all well and good, but if you take a look at that image, you can see that the background has a gradation to it. And whenever you have gradations, you're going to have a little bit more difficult time analyzing that image. You want things to be uniform if possible. So the first thing people will do is maybe do a diffuse front illumination. In that case, you're diffusing the light to give yourself a more even illumination of that subject and come up with a better image. Dark field illumination is one where you shine the light basically at a 90-degree angle from your camera. So you'll shoot from the outside, and basically you're just going to be looking at the high points. And you can see in this example that with the dark field illumination, those pins pop up. That's just 9-pin connector, obviously. And then the last one to talk about is backlighting, which is just like it is. You shine a light behind it, and anything that comes through as white. And you could see in this example that finding a missing pin would be a breeze. It'd be really easy to see that. Now, all 4 of these are valid. None of them is particularly better than the other, but you can see that what your end goal is going to determine which of those is going to work best for your application. I'll go back to this idea of the single color LED. So let's just say, for example, you had that label and what you cared about was the blue text, the blue part of the logo and the text Pepsi. If you had a color camera and you had a white field, you had a white lighting source, you could probably figure out the processing you'd need to be able to pull that information out. If all you had, though, was a monochrome or a black and white camera, you can see on the upper right, that image would actually be difficult to process because you're dealing with the diet, the text diet, and you're dealing with the top of that logo, which is red. The intensity is about the same, and so that makes processing a little bit more difficult. If instead you use a red LED, all the red information goes away, and you're left with just the Pepsi in the bottom of that logo. So you have a couple of different ways that you can configure your system. You could go with a color camera and white light, or you could go with a black and white camera and a red LED. And in general, I'll get into the cost of things, but black and white cameras are cheaper. So you might find that going out and buying a red LED solves your problem instead of having to do color analysis. And then the last thing I'll just talk about with acquisition is the idea of using different filters. There are a number of different types of filters, but one of them is polarizing filters. A polarizing filter is really handy for basically getting rid of reflective light due to all sorts of cool physics. But you can see in the top image there are these hot spots where the light is reflecting off the top of the capsule. If we use a polarizer and we set it up correctly, you can see that those hot spots go away and you're left with an image where you can easily discern the text on those pills. Okay, so I just did a speed run through image acquisition, right? Or just the lighting, actually. I haven't even gotten all the way through acquisition. And so this is a time where if this is your first time getting into image acquisition, I highly recommend that you go to, I guess they call them, what is the name exactly? Source experts, basically. Somebody that knows image acquisition to get started on your first job. And I may be able to help you with that, with sort of helping you develop your first one. But there are alliance partners out there like GrafTech who basically specialize in vision and can help you get started on all of this. So be that as it may, we're going to keep going with image acquisition. And now we're going to talk a little bit about cameras and lenses. Now, as you can see in that image, there's a wild assortment of camera bodies and lenses and mountings and all sorts of stuff like that. We're not going to cover any of that. There's too much information. What I am going to talk about are general topics that you're going to want to consider when you are developing a system. So, well, first I'll talk about some example manufacturers. Basler, I think, seems like that's the I think all NI's cameras, all our non-smart cameras are Baslers. You'll see those all through the industry. FLIR seems to specialize in thermal cameras. Cognix is smart cameras. And then there are other companies like Festo, for example, which I always thought was just doing valves and flow control until I went searching on the web and I found out that they're in the vision game too. So there are a lot of companies that are now producing cameras. And then the two types of cameras that I'm going to talk about today are monochrome, that is black and white images, and they come in 8 and 12-bit versions, maybe more as the things mature, and then color cameras. The thing to remember with color cameras, unless they're specialty, is that each color is still only going to get 8 bits of information. There are other specialty cameras out there, like thermal and line scan cameras. I'm not going to cover those. So when you are considering the camera, and I'm sort of talking about field cameras or field view cameras, that is, there's features that you're going to want to consider. First off is a spatial resolution, right? You're going to need to take a look at what you're interested in and say, well, how detailed do I need to be? How many pixels do I need? What is that resolution going to be? And the rule of thumb in general in the industry is that you want at least 3 pixels per smallest thing that you care about. So if you're looking for cracks, you're going to want to make sure that between the camera that you choose and the lens that you choose and the orientation to that object, that you see at least 3 pixels on that. And you would want to say that, like, wow, okay, well, if I need 3 pixels, let me get something that's got 20 pixels, you know, and then wouldn't that be awesome? And that's not what you want to do. And the reason why is that the larger the image, you're gonna take a hit with throughput, that is your frame rate necessarily, and then also analyzing that many pixels is also going to increase. So if you're looking for something that goes really fast, then you're going to want to make sure you sort of minimize the size of the image that you're collecting. And like I said, frame rate, that's the other thing that you want to consider. How quickly do you need this data to come into the computer? In general, the faster the frame rate, the more expensive a camera is going to be. And general rule of thumb there is just make sure you get something that can go faster than what you need. Don't be on that hairy edge of, okay, I needed to collect data 20 frames a second. I'm going to get one that collects at 20 frames a second. Well, as soon as the computer decides to burp, you know, you've lost that. And so you're going to want to have something that has a little bit better capability. So this slide is just sort of a top-level overview generalization about the differences and the pros and cons of using color versus a monochrome camera. All things being equal, a monochrome camera is going to be cheaper than a color camera. In terms of frame rate, again, all things being equal, a monochrome camera is going to be able to get faster frame rate than a color camera, and that's mainly due to the amount of data that it has to transfer. Even if the pixel sizes are the same, a color image is going to take 4 times as much data to pass back. So you're going to have a hit in terms of frame rate there. Obviously, if you have an application that needs a color image, you're probably going to need to have a color camera. That being said, if you can play around with it and use filters or colored LEDs, you may be able to get away with still using a monochrome camera. Pixel resolution, same sort of thing. Monochrome is going to be better than color. And then in terms of the analysis algorithms in LabVIEW and just in general, they've been optimized for black and white 8-bit images. And so they are going to be faster and more efficient than a color analysis. Granted, that is a snapshot as of today. Who knows what's going to happen in the next few years? Everything may come up to speed. And then the last thing is if you have a low contrast image, something that basically is many shades of gray, you may want to go with a monochrome camera with 12-bit instead of 8-bit resolution. 8 is a standard, 12 is a little bit more. That'll give you a wider range of pixels basically per value. Okay, so we've talked a little bit about lighting, we've talked about cameras. The next thing we're going to talk about is how we get that information from the camera back into the PC. And back in the day, or originally, the way you did it was with frame grabbers. And there's still frame grabbers out there, which basically allow you to quickly pull information off that camera onto the PC. They're usually proprietary per company. So NI has one, Basler has one. I mean, I'm sure all these different companies have their own versions. More and more people are using interfaces. So the cameras themselves are digital. They do the digitizing and then they send back the data in a digital form in these interfaces. And the three most common right now are GDVision, which uses Ethernet, USB 3, and then Camera Link. If you use GigE and use Camera Link, you are going to need a PC slot in order to use those. USB 3 obviously needs USB 3, but most PCs come with that. So let's just talk about, let's not worry so much about the frame grabbers. Those are usually specialty applications, but just talk in general about the interfaces and the pros and cons of those. And again, you know, some of these are better than the others, but it really depends on your particular application. If you have an application where the cameras are going to be very far away from your PC, or you need to have multiple cameras talking to the same PC, then using something like GigE would be the way to go. However, they only have a bandwidth of 100 megabytes per second. So that just means that if all your cameras are streaming at the same time, you're not going to be able to collect all that data. USB Vision has a little bit better bandwidth, but it has lower distances. You can only put them 8 meters away. And then the one with all the frowny faces is Camera Links. But Camera Links, if you can see that the advantage to Camera Links is its bandwidth. It basically has, 8 times what GigE can do. And the other advantage it has over GigE, for example, is the idea of this real time. And real time only means that you need to have precision on when data is collected and acquired and brought back into the PC. So if you have a very high speed, very time intensive application, then you're going to want to use Camera Link. But as you can see, it really depends on what your final application is going to be. So the last thing that we'll talk about in acquisition is the drivers themselves. And that's what we care about, right? We're LabVIEW programmers, I assume. And how do we get this information into the PC? Well, NI has 3 basic drivers. They have the iMac driver, and they have the iMac DX driver, and then the iMac IO. iMac is only for the NI product line, and this is very small text, but if you go up online, you can probably find it. But bottom line, it's their cameras, their Camera Link drivers can use iMac. Pretty much any third-party driver, or any third-party camera, I'll say, is going to use the iMac DX driver. And that's going to include the GigE cameras, the USB cameras, if they have the right drivers. And then I guess it says FireWire. Nobody uses FireWire anymore, but it's still up there because NI hasn't updated their website for a while. The iMac IO is similar to the RT. This is for their FPGA smart cameras and stuff that you would need. And it's a smaller driver set than the other two because obviously it's RT or FPGA. So that being as it is, I'm going to give you a little example in Max showing you, and that, I guess that's the beauty. So because we have these drivers, we can use Max, I should say, like that. So when you get a new camera in, you can install the right drivers and use Max to sort of get a peek at what's actually happening. So let me give you an example of that. So let me switch over. Hopefully it'll come up. Yep. Okay, so I'm sitting here in Max, and you obviously have to have the right driver installed. So if you see down here in the lower left, I installed iMac, and I also installed iMac DX, and that's really the one I'm going to need. I think you have to specifically install it. It doesn't come, you have to go through the installer and specifically choose it. What I did was I went out to Best Buy. I just got a cheap webcam, so it's just plugged into my PC. And looking at it right now, there's nothing happening there. There's a couple things to note, and this is a terminology thing. An image, snap is snap. It just takes a single image, and grab is just like, basically grab is saying continuously continuously acquire data for me and show it up on the screen. So I can play with my lighting. So you can see here that that's not bad, but it's not too terrible. I could give it another light source just with this flashlight, and you can see that, well, yeah, it's much brighter, but I can see like I can see the lens, and all I can do now is put a little diffuser on it, and now you can see that I have a much better image just with something simple like a piece of Kleenex over my lighting source, as opposed to something like this, which is flooding that camera. So simple things like this diffuser are, always use a diffuser if you're using front imaging like this. But anyway, otherwise you're going to be trying to deal with the actual light itself. You're going to be fighting that. Other things to note in Max here is that down here at the bottom, when you're using the IMAX DX driver, you'll often see that there are some parameters that you can change on the camera. This changes from camera to camera, and it also may not be everything that you can possibly change. Sometimes you'll have to use their software in order to make changes, but it's a start. So that's how you can use Max. Okay. So going to my next slide. Okay. So now we've gone through, again, speed run, right? We've gone through lighting, we've gone through cameras and lenses, we've gone through the interface, the driver, we're done with the acquisition, we've managed to grab some images and brought them into the computer. Now what do we do with them? Well, first thing we're going to want to do is process them. And again, the whole purpose of processing is going to be to separate out the object and the thing that you care about from the background. The other things that you can do would be to manipulate it, change the gain of the image, or account for the fact that the lens may not be giving you a square image, the aberrations of the lens themselves. Some of the functions that you might have that would sort of fall into the processing image bucket would be things like equalizing the image, thresholding the image. Thresholding is a place where you basically select a value and say, I want everything above it, I want everything below it, and that's a way to separate out bright things or dark things from the background. You can filter out, once you've done that, you could bring a filter in to get rid of small objects or large objects if you're interested in something in the middle. Edge detection is a function that's in there, so sometimes you can look at that transition. ROI creation, and ROI is region of interest. So you can go in there and you can select part of the image and say, I just want to analyze this part. You can do that with processing functions. You can do pattern matching and also maybe some background subtraction, which I use that a lot in microscopy to get rid of sort of the gray background to sort of equalize it. If you go into LabVIEW and start looking at the palettes, underneath, once you install Vision, underneath the palette, there is, underneath, I guess it's motion and vision, there is image processing, and inside of image processing, there are various palettes. And I've just expanded on the processing palette, and you can see that there are 16, 17 different functions there. And each of these palettes are going to have similar number of functions. And if you start reading about image analysis, a lot of the terminology they use, there's a similar function inside of LabVIEW, okay? So that's processing, again, high level. And then where processing ends and analyzing begins, it's a little bit fuzzy. I like to just think about the analyzing being the part where you're actually extracting the information that you care about. Examples for that could be like, okay, how many objects do I have on my screen? What are their sizes? What are their intensities? Are they there? Are they missing? All that kind of stuff. And again, there are a couple of palettes for that on the block diagram. Still underneath the image processing, there's an analysis palette. And then if you go into machine vision, they have palettes and subpalettes and subpalettes and subpalettes. And so you can see that like there's a lot of stuff to try and figure out, right? Okay, and I imagine anybody that first comes into this is like, how the heck am I going to get started? Well, luckily, NI does have a package that will help you out with that, and that is called the Vision Assistant. So, what the Vision Assistant is it's a standalone package, It's basically it's a prototyping application. And what it allows you to do is take in images and build a script that allows you to process and analyze that image without having to go into LabVIEW. Okay. It's got a lot of advantages. And I'll show you an example of this in just a minute, but just to give you a sort of a lay of the land. The upper left-hand corner is going to be sort of where your raw images are. And then you see at the lower left, that's where the script steps are going to be. So as you decide you want to, place different analyzing or processing steps, that'll be displayed there. Lower left is either going to be, if you're in between steps, it'll allow you to add a new step. And then if you're in a step, it'll often have details about the settings for a given test step or script step. And then the upper right is going to show you either the processing image or, as you are configuring that screen, it'll sort of show you, or configuring that step, it'll show you the results of that particular step. There are two great things that come out of this tool as well. One is that once you're done, you can actually export this to LabVIEW. So, and then from there, you can implement it and integrate it into your application. And then number two is that this has a performance estimator. So what you can do is you can build these scripts and test them out on your test images and then get a feel for how much time is it going to take to do this analysis. And that will then be, you can then use that to decide, well, what's the frame rate that I could actually be running these applications at? So with that, I will give you a quick little demo of the Vision Assistant. Okay, time out, okay. So come out of here and bring up the Vision Assistant, which should have been up, but is not. Of course not, come on. What I'm going to show you here is, once it comes up, come on. There it is, okay. So there it is. So the other really handy thing about the Vision Assistant is that it has a whole assortment of examples. They call them wizards. Yeah. Okay, so here it comes up. Okay, I'm sorry, this should have been up before. When you first bring up the Vision Assistant, it'll actually ask you sort of what is your target? What are you planning to do with the final application? And that, I believe, will change the folders and the steps that you can choose from. So you can see that I'm going to be using LabVIEW. So I'm just going to go there. And like I said, if we go under Help, there's this Solution Wizard, which basically is a list of some just simple examples of various possible applications that you could use. And so I'm going to show you under pharmaceutical, and I don't know why, there's a dental floss inspection. I'm going to load the solution, and what it's going to do is it basically loads up some test images and it loads up the script. And for whatever reason, I think it's my version of it, it very poorly brings up the help. But if you get rid of this text, I don't know what it's doing exactly. But if I get rid of this text and I type in dental floss example, all of these examples will have a help page. Sometimes you just have to look around for it. But what it's going to do is it's going to tell you what steps it's using and why. So let's take a look at this step. So first thing I'm going to do is I'm going to look at the images that are brought in on this example. And the purpose of this example is that you have this dental floss tool. And it consists of some dental floss in between those 2 points. And the white blobs there are supposedly toothpaste. So it's looking both for the presence or absence of the floss and then the presence and absence of that toothpaste. And the other thing you can see in this particular example, what they're doing is they're showing you that it's an example of pattern matching when the object itself is not always in the same location. So if I go to processing images, down here in the script steps, there is acquire image, which is exactly that. In this case, it's pulling the image from a file. This step, I just double clicked on it so it showed me the details. So what this is doing is it's doing a pattern match. And part of building the example was somebody went and pulled a a snapshot of a region that they want to match on all of these images. And so this obviously would be, if you were building this from scratch, this would be the part where you'd have to spend a lot of work finding a good example area that that basically would be the same on all of the images that you cared about. Say, okay. The next thing it does is it resets the coordinate system. So what it does is it says, okay, I found this region of interest. Now I'm going to reset my coordinates so that instead of, dealing with the image like this, we're going to deal with the image at an angle. Because in the next step, what they want to do is they want to grab the green boxes, which are the regions of interest, and get information about those. And obviously, in order to always grab those regions of interest at the same place, you need a new coordinate system. What's up? Why'd it go away? Okay. Whew. So you can take a look there. And then the other thing you could see now is down in the right is information about each of these regions. One being the blob on the left, the toothpaste on the left, 2 being the toothpaste on the right, and 3 being the floss. And so if I look at this, I can see, I don't know if you guys can see, but I can see that the area 2, which is the floss, has an average intensity of 28. Now, one of the things I can do is I can click on this next button, and it will show me the next image and the processing. So you can see there it found it. There it found it. But in this case, you can see the toothpaste has gone on both sides. And if you were to look at the average intensity of those, you'd see it's much lower. And same sort of thing here. Same sort of thing here. And again, yeah, that's what I wanted to show. So now we have one where there is no dental floss. And if I were to look at the average value of that region of interest, it's only 3. So now you can start thinking about, well, how am I going to build a filter so that I can detect when something is missing? And then in this case, when the floss is frayed or something. In this case, that average area is 57. So obviously you would need to process multiple images to start to get an idea of, so the average intensity when there is floss is 30 plus or minus 5. When there's nothing, it's less than 5. When it's above 40, then I know that I've got something wrong with it. So if I get out of this, the other handy thing that this can do, I can turn this on. If I turn this play button on, what it does is it goes through all the images that I have stored and sort of reruns those analyses over and over again so that I can sort of see whether or not my particular algorithm is working, my particular scripts. And then the last thing, well, there's two. Underneath the tools, you basically can say create LabVIEW VI. I'm not going to show that here because it actually takes a little bit of time. But bottom line, what it will do is it will sort of walk you through where you want to save it. And then if there are parameters you can add, it's got a lot of checkboxes and different things that you can do. You aren't probably going to be able to use it just as is, but you can probably pull that apart and then build it into your final application. The other thing you can do is here, there is this thing called the performance meter. And what the performance meter does is it gives you sort of an average time that it took to, that it takes to run this particular application. That is, obviously you got to take that with a grain of salt because it's only on this particular PC, so, but what you can do that's probably even more helpful is you can look at each test step and see how much time it takes. So in this example, the average time was about 10 milliseconds to run this. But of that 10 milliseconds, that find routine was taking 8. So with the bottom line in that is that pattern matching actually takes a lot of time. It's all relative, but it takes a lot of time. So if for some reason you needed to have things faster than, what is it, about 100 parts per second, if you needed to have 1,000 parts per second, you're going to need to do something to your system to make sure you don't have to pattern match. And what that might be is making sure that they always come in a certain orientation or those types of things. So those are the games you can play here. Okay. So let's go back to my notes. Okay, so the last section that I'm going to talk to you about is the idea of displaying. And this is where we're finally going to sort of get into LabVIEW a little bit. And I'm going to talk a little bit about the LabVIEW image buffer because it is a little squirrely and it has some non-intuitive behavior, the UI display, and then the idea of non-camera sources. So when you're using image processing in LabVIEW, you're going to create an image, and basically it's an image buffer. You create it, you set up the type that you want, and basically any sort of functions that you use are going to reuse that buffer, or you can potentially reuse that buffer until you dispose it at the end of your project. What this means is that there are some funky things you have to worry about or be careful of. One thing, do not branch, okay? Because in the top example, I am basically adding 5 to my image, and then the bottom track, I'm subtracting 6. But they're both working on that same image buffer. They're both going to output onto that same image, and now you've got a case of race conditions or just really squirrely behavior, and like, what the heck is going on? And that's because both of those outputs are the same image buffer, I should say image buffer. If you want to do something like that, where you want to do one sort of function with the image, and I want to do something else to it, it's best to copy it. So you make a copy of it, and now the top track is working on image A, bottom track is working on image B buffer. I'll just say, I'm going to be using image and buffer interchangeably, but think about it as a buffer. It's not unlike a DVR in that respect, except it doesn't have, it's done under the hood, so you don't know about it. The other thing to worry about when you're using these buffers is to be careful of shift registers, okay? So in this example, you would think that, I'd need a shift register on that first, I wonder if I can room that. I don't know if the mouse can show this. Can you see the mouse? No, you cannot. So you would say, well, these guys should have shift registers. But the way that I've built this, most image processing functions are gonna have the image and then a destination image. In this case, what I'm doing is I'm taking and I'm adding image 1 and 2 together and placing the results back in image 2. So that means that coming out of that function is actually image 2 buffer, not image 1 buffer. If I were to put a shift register in that, the second time through, it would be image 2 plus image 2. It just would blow up on you. The other thing to note is that you don't need a shift register for image 2, because again, the output is going to image 2. The next time through the loop, it's going to look at image 2 and use the results that are in there. It's a little non-intuitive, and so just be careful. The other sort of cool thing about it is if, for example, you want to display on the front panel, you would think that as the process is being done, I want to create local variables and update it as the process goes on. You don't have to do that because the image is updating. The front panel is going to update as the image updates. So, and the bottom track is actually the way you'd want to do it. That is, of course, unless you select something called snapshot. If you select snapshot, it's basically going to look at the image at that particular point in the process. Okay? The other thing to consider when you're dealing with these buffers is that they are a finite resource. You really should minimize the number that you use and either close them or reuse them when you're not using them. It's probably less of an issue with most modern PCs. It's probably a bigger issue when you're doing the FPGA. So it's just good coding practice. Second to last? No, there's a couple other things too. The display. This is a user interface display. It's quite handy. You can see the image. You can look at the details, tell you a little bit about the image, like how big it is and whatnot. And then there's a lot of region of interest tools on the left. This is great for displaying things as the process is continuing, giving the user feedback. But you can also use it as a control and allow the user to do things like select a region of interest that you then have the computer process that data. Again, if you right mouse click on it and say snapshot, it's basically going to be showing you the image buffer at a particular point in the process. So the second to last thing I'll talk about are the idea of using non-camera sources. So we've talked about pretty much like you get a camera and you bring the image in, but there's actually functions that will allow you to either pull images from a file or to do, pixel manipulation. There's a whole palette of pixel manipulations. So for example, I'm working with a camera right now, a thermal camera, which doesn't have any sort of interface. And so I can talk to the DLL, pull out that 1D array that they give me of single numbers, resize it into a buffer, and then using the array to image will allow me to take a 2D array of values and push it into an image buffer. And then once you get in an image buffer, you can use all the image processing tools that are there. So there's that. And like I said, there's a whole palette for file I/O, saving and reading from file, and also pixel manipulation, which basically allows you to, like I say, push data from a 2D array into an image and likewise pull data out if you need a subset. So the last thing I need to talk to you about, which is the unfortunate thing about Vision, are the licensing agreements. Vision, unfortunately, is not a free thing. You do need a runtime license if you deploy any of the Vision tools or the iMac DX driver. It is a perpetual license, so that's a good thing, but any machine that you deploy this on is going to need that. If you're going to be deploying this on hundreds of machines, you may want to talk to NI about getting a bulk discount, but in general, that's what you're going to need. It's also a reason why you'd want to go with an executable instead of the runtime environment, because that's also an add-on. I don't believe it comes, I don't know. You can see this tree is complicated. I would definitely call NI, find out what your application is and which of these particular tools you're going to need. Okay. Any questions about that? I guess I should ask. Okay, so in summary, what we just did was a blazing speed run through image acquisition and analysis. Doesn't even start to touch all of the different things like optics and cameras and all that kind of stuff. But a couple of takeaways that I think you should take from this. One, you can use Max. Use Max to help you both start to get information about your camera, and then you can also use it later on to do things like focus and make sure things haven't bumped. You can use the Vision Assistant to develop and decide on a particular algorithm. Gets you up to speed a lot faster than trying to build this up in LabVIEW. Be aware of ambient light. Any LabVIEW experts out there have been bitten by the ambient light. It works perfectly here, but then I take it over there and it doesn't work because there's a light under it, right? Or over it. So just be careful of that. Try to control that environment. The better you can make sure that, like I said, ambient light is an issue, temperature is an issue, whatever, you're going to have a better time and a more robust analysis instead of fighting the fact that you're dealing with ambient light changing. The other thing is don't do this alone. If you're jumping into your first image acquisition project, talk to the experts. There are lots and lots of tools out there on the internet. There's lots of experts in the room here, a few experts in the room here. We can help you out with that first project. If you're interested in doing more, here are a bunch of references that I pulled off the internet, some different, there's different stuff up on the NI website, and pretty much every camera manufacturer has various tutorials and knowledge base and that type of thing. If you have any other questions, feel free to find me. With that, I am done. Any questions? Oh, yeah.
Hi, it's been a minute since I did a lot of Vision stuff, but back in my day, we like to use cameras that have all the built-in analyzing and processing into the device itself.
Sure.
And insert that into my LabVIEW program, and mainly boil down to licensing. What would be your preference? Would you prefer something that uses NI Vision or something that was built in?
It comes down to the final application, I think. That's one where you have to do, like you said, the cost benefit analysis, like the cost of the camera versus the license, versus the ease of being able to change things on the fly. That's a hard one to answer without knowing all the details of the particular project. But you're right. There are a lot of smart cameras, and I have some smart cameras. I think you're probably talking about Cognex maybe or something, or
It's been too long for me to remember.
Yeah, and you're right. There's unfortunately for all vision stuff, it seems like there's a license somewhere down the line, and whether you have to buy it for the LabVIEW application or for the camera itself. I can't answer that without knowing more details.
Hi, Katya. Thank you for your talk. Appreciate
Thanks.
it. Very informative. We were talking about this during lunch. I have comment and question. First, a comment, and I only want to say it because I think it's valuable for our audience here. A lot of people may not be aware. It can be confusing. We went through this over the last couple of years ourselves. But what comes with LabVIEW is something called the NI Vision Acquisition Software. That software connects to most cameras. It will get you up and running. It gets Max working. Surprisingly, you can do quite a bit with it. You can capture images. You can then save them to JPEG, a number of other formats. For instance, you can do some rudimentary cropping. And sometimes your processing, if you will, is so simple, like a simple image subtraction. You may be able to write an algorithm yourself. That being said, and I was just looking this up just to verify, the Vision Assistant, I had trouble finding it. It is buried within the Vision Development environment.
Right.
The Vision Development. That's the one you pay for. And it's fairly expensive. There is a trial period and such, but it's a separate piece of software. I forget if there's a subscription or one time or whatever.
Yeah, since NI's changed, so there are a couple of comments about that. So that what you're saying is true. So there is the iMac toolbox or palette, and yes, it will let you like snap a picture and save it and do some rudimentary stuff like that. That's only if you're using iMac drivers. As soon as you go to the iMac DX, you're going to have to pay a license for the iMac DX driver. The second thing that I have found about that is that just that display VI that I showed you that's so nice, the front panel item, that's part of the Vision, not part of the iMac. So as soon as you want to sort of display it nicely, now you're into Vision and you're starting to have to pay for that license. Yeah, you have to take a look to see how they split out their licenses. That's why I said that tree is complicated. In theory, you can get Vision Assistant without necessarily having to get the LabVIEW development, but LabVIEW development includes Vision Assistant. So it's a bit of a, so like if you were using C, for example, you could in practice or in theory, get Vision Assistant without having to get the Vision Development System. It's complicated. You saw that tree. Go to NI and talk to them about that specifically. I think I might have the, it's the one at the very bottom there is the licensing tree. And and now that they've switched to more of a subscription versus perpetual license and stuff, it's all changed too. I don't know the answer to all that.
And just one quick question, just out of curiosity, because it's been a while for me. I started with frame grabbers, camera link, more complicated. Also, analog camera. Do you have any calls from customers still working with they have perhaps legacy analog, and then you are stuck doing all the work? I was just curious.
No, I haven't. Like I said, I get a project for every 3 to 5 years. Right now, I have 2 projects, and both of them are sort of like proprietary and don't actually even use cameras. I'm taking 2D arrays and bringing them into the image world, not getting them from cameras. I would think that the hardest part would actually be finding the frame grabber card to go with it in this day and age. So, yeah. Anything else? Well, thank you very much, guys. Appreciate it.